All right. Welcome. Wednesday, March 22nd. It's my dad's birthday today. That doesn't matter though, but still. So from last day, right, we introduced some new formulas, a lot of new formulas, right? And we use them to solve kind of more complicated problems, right? We were solving annuities. Annuities are whenever we have these regularly occurring payments, right? And we know how to find unknown payment amounts, right? So they're going to pay an amount a year from now, and then the same amount 2 years from now, and then maybe 3 times that amount 4 years from now, and how much does he owe, that kind of thing. We know how to solve those, but now we have these regularly occurring payment amounts. So in terms of kind of review, right, we introduced these formulas here. Okay, so I guess kind of in terms of review, we introduced these guys here. And so we introduced annuities, which are regular payments, and we're going to call these ordinary annuities. Oops, I didn't give myself enough space here. Ordinary annuities. Okay. Ordinary annuities are regular payments, right? So PMTs, regular payments made or received at the end of the payment period. So at the end of the payment period. Okay. So we've seen questions that that kind of highlight, okay, at the end of each month or at the end of each week, right? And so then you have these ordinary annuities, they're called. Okay, and I guess I wanted to kind of write here. Let me clean this up a little bit. There. So we can solve for the future value, the present value, right? Notice that, right, when solving for the future value, right, usually the present value is 0, right? We start with nothing. Usually PV is equal to 0. Not always, but usually. Okay. And the same thing, right? If we are trying to figure out what lump sum I need, for example, to receive some payment amount for some number of payments, right? Then usually at the end of that, I've run out of money, right? So then the future value is 0. So here, and when solving for PV, usually FV is 0, right? And so that's why we need 2 different formulas. Okay, this is why we have 2 different formulas, right? They're similar looking, but they definitely do opposite things. 2 different formulas. Yeah. Same thing when you're calculating N, right? N is the number of payments. And so let's highlight that here. N is the number of payments. And depending on if you know the future value, right, or if you know the present value, that's going to determine which formula to use. So there are a lot of formulas, right? But given the information that you have is going to determine which one to use. And of course, if you're solving for the payment amount, right, again, it's determined, which formula to use is determined by if you know the future value or if you know the present value. Yeah. So here, let's see here. I'll start by doing that one because it's kind of the one in order. When solving for PMT, we use these formulas, right, depending on if we know the future value or the present value. We use these formulas depending on if we know FV or PV. And again, if we're solving for the number of payments, right, the only change or the only variable that's different in each of these, besides the layout, right, is whether you have the future value or the present value. So the number of payments, right, depending on if we know FV or PV. So we use these formulas, we solved some problems, and today I want to start by showing you how to use the calculator to solve these problems. Okay, so 6.5 is using the calculator. 6.6, I'll say that we're kind of skipping 6.6. It summarizes the general strategies for solving these problems, but that's what we're doing all along, right? As I'm kind of highlighting things to keep track of. So it's worth reading, but let's say here we're skipping 6.6, general strategies for annuities, since we are introducing it throughout. Okay. So we're not really skipping it. I've just kind of smeared it all over the chapter. Okay. So 6.5, using the calculator. Okay. So we can solve annuities problems or annuity problems using the calculator. And so we can use the calculator to solve annuities. When we're using the calculator to show our work, right, we just write out all the inputs that we're giving the calculator. So you're more than welcome to use the calculator, okay? And I encourage you to use the calculator because I think now that we're dealing with these kind of bigger formulas, right? They get tedious. It's not that you can't solve them. Of course you can solve them, but we're able to solve a lot more complex problems if we use the calculator. So I encourage you to be very comfortable with using the calculator and using it on quizzes and the test, unless it says otherwise. Okay? So, and I'll give you a heads up on the final exam, if there's one where you have to show your work and you have to use the formulas, I'll give you a heads up, but off the top of my head, I can't remember if there is one on the online final, but anyways, to show our work, when using the TVM functions, so this is, I think, time value of money functions. Usually it's just referred to as TVM functions. Okay, so to show work when using the TVM functions, right, the calculator, we must list all the inputs. Okay, we must list all the inputs. Okay, and we've seen this list before. I'm just going to add one more item to the list, and then we'll be complete. Okay, so the list, if we go to, I wonder if I can have it like this. Yeah, looks like I can. Right, so how I want the list in this order. Now, in a lot of the Moodle questions, there will be just inputs, so then you'll just put it in the appropriate spots, right? But if you're showing it in your written work, then I want them in this order, because otherwise, if I'm, reading things too quickly, I might miss it something, or so make sure you use this order. So you've got N, the interest per year, and I wonder if I can use my, I can't use my pointer on the calculator, but so I'm just moving across the buttons, right? N, interest per year, present value, PMT, and the future value. Okay, and then we're also going to have the payments per year, and the new one that we're going to introduce, and maybe that's what I'll do. Maybe I'll take a screenshot here so that I can. Oh, that's what I get for using a free app. There. No. Ads. What if I have it like this? How about that? Okay. So what I'm doing is I'm going across, and maybe yellow would be better. Okay, and I'm listing all of these values. Then I'm listing this one, and then the one that we're going to add to the list is going to be this one, the beginning or end. Now the default is the end, right? Payments are made at the end of each payment period, but in chapter 7, then they'll be made at the beginning, which is going to change our values just slightly. Okay? But we'll leave that for chapter 7. But that's why I want to add it to the list, because then our list is complete and we'll be able to use the calculator more efficiently in chapter 7 as well. Okay, so I'm just moving across here and listing the values, the interest per year, the present value, the PMT, the future value. And then if I go into, so second, payments per year, first thing that appears is the payments per year. Then you scroll down to the compoundings per year, right? And then we're going to have the mode, beginning or end. So, and did I? Beginning or end. Okay, this one is new. For now, we leave it in the end mode, which is the default setting anyways. Oops. Okay. But that's the only change that we have to make in chapter 7. So that's kind of exciting. Okay. A couple of notes, right? So N is what? Now N is going to be the number of payments. Okay. And so this is the number of payments now. Whereas before, when we didn't have regular payments, right, N was the number of compoundings, but that's not the case anymore. Okay? The interest per year is the annual interest rate, but not as a percentage. Okay, so it's the interest in percent. So that is 7% means that the interest per year equals 7. Okay, so that's important. The present value is the present value. Now, let's see here. What's one key thing that we mentioned before? We had to keep track of, okay, the present value and the future value. Sorry, the dog's all tangled up there. The present value and the future value have to have opposite signs. And this is where it's going to be really important that you have a negative for money moving out of your hands, right? So even if you're putting it into your savings account, it's leaving your hands, right? So then it would be negative, right? And then whereas money coming to you is positive, okay? And so must have, oops, I can't write anymore. Oh my gosh, I need to start over. There. Must have opposite sign from the future value. And same thing, must have opposite sign from the present value. Yeah. Otherwise, you're giving money, and then you're not able to find anything, right? For example. Now, the PMT is the payment amount, okay? So this is the payment amount. It's going to be negative if it's leaving your hands. So if you're making payments, it has to be negative, right? And so negative if making payments, and this value has to be positive if getting payments. So you can see, right, if I start with nothing, right, that's possible, okay? And then if I'm making payments, right, so money's leaving me, then I'm gonna have a positive future value, right? So I'm making payments, so they're leaving me, so they're negative, and then at the end I have a future value, okay? The opposite would be if I have some amount saved up and now I retire, for example, and I want regular payments coming to me, okay? Then I've deposited this amount into some account, right? So it's left me, and then I'm getting payments, so now these are positive payments, okay? And then in the end, I have 0. So the payments per year is going to be, what color haven't I used? Purple. Payments per year, which we've been calling F2 in our calculation, right? And then here, this is our compoundings per year. Which we've been calling F1 when we calculate I2. Right. Okay, good. Think we're ready. How about we redo the last example that we did, but on our calculator, right? Because then we'll be able to see the two side by side. Okay. And so here, let's redo example 218 on our calculators. Yeah. So example 218, oops, wrong one. Here. Copy. Paste. So we already solved this, right? And so maybe what I'll do is I'll just grab, you know what? Let's start fresh. I think it's going to be good practice just to read these again and just practice identifying information. Okay. Suppose month-end payments of $300. So that's the payment amount, right? So PMT is 300. Now this, when we're using the calculator, right, that's when we need to pay attention to if money is leaving us or coming to us. And so if I'm making payments, okay, then those are going to be negative, right? So negative 300 on calculator. The time is 4 years, right? T is always in years. If the rate of interest is 5% per year, oh, you know what? I forgot something. Payment frequency, right? So the payment frequency is, and maybe what we'll do is we'll say F2 is the payments per year, which is monthly, which is 12 times per year. And then we'll just kind of sit on this for a little bit, right? They're at the end of the month. That's all we have so far, but it's good to pay attention to it. Now we can deal with the interest. So the interest is 5% per year. So R is 0.05, right? But the interest per year is 5, right? In terms of the calculator inputs, and compounded quarterly. So then the compoundings per year, which used to be F1 in our calculations, right? F1 is the compoundings per year, which is quarterly, which is 4. What is the value of the car, which means that we want to find the present value, right? I have received some amount essentially to pay off the car, right? And then I have to make payments to pay it back, okay? At the end, what should my future value be? It should be 0, right? I shouldn't owe anything else. Okay? So on our calculators, we're going to have N, we're going to have the interest per year, we're going to have the present value, the PMT, and maybe I need to, because I want to keep it all on the same page here. So PMT, the future value, the payments per year, the compoundings per year, and oops, if it's beginning or end. I encourage you to use the same kind of methods that we used earlier. So the thing that you want to solve for, right? I'm going to put an asterisk beside it, right? Just to show that, hey, this value, whatever I put here, that's actually the one I solved for, right? Okay. Here we go. N is the number of payments. Okay. So N is the number of payments, and we made month-end payments, so 12 payments per year for 4 years. So it's going to be N is F2 times, or I shouldn't mix up the order there, time times the frequency, but frequency 2, because it's the payments per year, is 4 times 12, which is 48. Okay. The interest per year is, we already said, is 5. Okay. The present value, you're welcome to enter 0 when you're entering it into your calculator. I'm just going to leave this entry blank, and then I'm going to fill it in with my answer. So you can do the same if you want. The payment amount, so this is where it's important that we have the negative 300. Okay. Negative 300. Like we said, once it's all paid off, the future value should be 0, right? The future value of the loan, once it's paid off after 4 years, we're forcing it to be 0. The payments per year is 12, and the compoundings per year is 4. And the mode, the only one that we've used so far is the end, but that's also because here, right, the end. Month end payments. Okay. All right. So how we do it, right, is we put the value on the screen that we want, and then we basically just kind of push it into a slot, right? So if I want 48 in my N, then I have to have 48 on the screen and then hit N, right? And it's not very rewarding because it doesn't show me, it doesn't acknowledge that it saved it really. So N equals 48, okay? And then you just back off and you just keep going, okay? So a little bit tricky in the beginning. Once you get used to it, it's fine, but I usually want kind of more of confirmation or I don't know what I need, but I don't know. But now I just move on to the interest per year. I want 5 interest per year, right? I'm going to put in 0 for the present value, just so that I'm just always filling all these slots. And then 300, but negative, right? That's going to be so important, right? Because we're making payments and going into the PMT, the payment amount. Future value is 0. I'm going to force it to be 0, right? I'm forcing it to be paid off. And now I can move into the payments per year and the compoundings per year. So I have to go into the second menu. Okay, so second, and then the interest per year button is the payments per year menu. It's already set to 12, so that's great. If I wanted to change it, I can hit 12. Remember, in the second menu, then we have to hit enter or set, right? So enter, then the equal sign appears, and then it's saved. Okay. Scroll down, so use the down button. And now I'm going to change the compoundings per year to 4. Enter. And then I like to scroll around and just make sure that they're saved the way I want them to, right? If I forgot to hit enter, for example, it would revert back to the old one. And so you just want to make sure that it's stored the way you want it to. Now, to get out of the calculator, the second menu, right, you're going to go second quit, which is second compute. Okay. And then in chapter 7, which I think we'll start today, I'll show you. Maybe I'll show you now. Why not? So like I said, this begin, oops, sorry. I overwrote my 300 negative in the PMT, so I should probably restore that. But I was trying to use my highlighter for the begin, which is above the payment. So then what you can do is you go second, hit the payment, and notice that so the default is at end, okay? And so I can't remember exactly. Okay, second set, right? Or second enter. And now notice how it has the little BGN up in the top banner, Okay, and so now the payments are at the beginning of the payment period. It's not what we want, so to change it back, you're going to go second, enter, and now it's at the end. Right, so that's good. So it's not too bad, right? We don't need that until chapter 7, but may as well introduce it now while we're here. Second, quit to leave the second menu. So now we're ready to compute the present value, right? And so now you're going to hit compute present value, compute present value, and we get 1332.18986. As long as you didn't round any values when you use the formula, that's going to be the same answer. Okay, in fact, oh, just wanted to get rid of this guy, but how? There. What did we find? This is what we found, 1303218986. I'm going to grab this copy. Same as what we found last day. All right, and I'll just put it in here. Oh, if it only gives you 4 decimal places, are you using this financial calculator that I'm using? Okay, so that's fine. So to change it,
Being an international educated nurse,
I this ad with me there. Oh, that's weird. I'll just show you how to change the decimal places. Sorry, I don't know why it's all spacey. Let me quit it. There. So to change it to show 9 decimal places, which is what you want, because otherwise I think it does rounding as well, which you don't want. So if you go to format, which is down above the decimal point, so second format, and then the decimals will say 4. And so just hit 9 and then enter. So I think it'll be like this, 4.00, enter, or something like that. So you want to change that to 9. So just plain 9, enter. And then that should do it. Awesome. That is great. Okay, yeah, because that would mess up some things sometimes. Not all things all the time, some things sometimes. All right, so we found the same answer. We can use the calculator. I often find that students are kind of they don't like the calculator initially, but then once you start to use it, it's a lot quicker, right? And so then, and like I said, you can solve bigger problems if you're using the calculator. So I encourage you to use the calculator functions, even though it's a little bit scary in the beginning. Okay. So let's do another practice question. Example 219, copy. What I want to do is we'll first solve it by hand and then solve it on the calculator, right? Because we haven't had a lot of practice solving things by hand. Okay. And so here we will first solve by hand, then using the calculator. either way, you're going to want to make a timeline because that illustrates what you're about to do. And it sorts out a lot of information that's given in the question, right? And so I always encourage you to make a timeline. And for in-person tests and things like that, the majority of the marks are for the timeline, right? And we can't do that because we have an online class, but usually the way you lay out your timeline tells me that, okay, what you were going to solve for makes sense. Okay, so Tom and Delilah wish to start a college fund for their daughter. Their goal is to put $200 into the account at the end of each 2-week period. Okay, so bi-weekly. Assuming that college fund will earn a rate of interest of 3.75% compounded quarterly, how much will be in the account in 20 years? Okay. So let's see here. We've got some information, and how about we highlight, the goal is to put $200, so the PMT is $200 at the end of each 2-week period. So at the end, which we'll keep up our sleeves, right? That's the default, so that's what we have so far. And then 2-week period. So the payments per year, which is your F2, okay, is going to be 26 biweekly. Next chunk of information, assuming that college fund will earn a rate of 3.75%, so R is 0.0375, compounded quarterly, so F1, which is the compoundings per year, is 4. Then if T equals 20, how much will be in the account? So that's the future value. Okay, what did we say the first thing was? I need to find I2, right? And so I2 from the formula sheet is 1 plus I1 to the power of F1 over F2, then minus 1. Yeah. That's the first thing that we have to solve for. What's really nice is by entering the payments per year and the compoundings per year, the calculator recognizes that these are not the same. So internally, it already calculates I2 for you, right? And then uses that. So by telling it that, hey, these are different, it makes that adjustment, right? So I2 is 1 plus 0.0375 divided by 4, right? I1 is the periodic interest rate originally, divided by 4, or sorry, to the power of 4 divided by 26, then minus 1. Let's see here. I2, I get 0.00143662. I'll use the Desmos calculator again. Okay. So I have 1 plus, and then I'm going to use brackets, 0.0375 divided by 4, close those brackets, to the power of 4 divided by 26, and then minus 1. No. Oh, what's my mistake? This bracket should be just here. You know what? Gonna delete this end bracket. 4 over 26 minus 1. There. I'm going to call this I equals. Okay. And I'll screenshot this, but not until we're done with all the calculations, right? So otherwise it'll be too many. Okay. So now I have I, okay? So I2 is now my I. I need to find N. Okay. But first what I'm gonna do is I'm gonna just draw out the question in the timeline. Okay, so let's say today is when they're going to start and they're going to save for 20 years. Okay, so each 2-week period, and if you have regularly occurring payments and nothing else is changing, then you can just do the first 2 and the second to last tick and then ... in between. So 1 biweekly, 2 biweekly, and then 20 years. N is time times F2, which is 20 times 26, which I have here is 520 biweekly. Making this 519 biweekly. To indicate that it just stays the same. There's nothing fancy going on here. But at the end of each biweekly period, they're going to make payments of 300 for 20 years. Okay. So then, let's see here. These are all going to kind of, I think of them as funneling into some future value, right? If you're putting money away, right? And then if we wanted to solve for the present value, right? They're starting with 0, so it doesn't really make sense. But if they were to be getting 300, right? Then that's worth something. They would have started with some amount. But here they want to know how much will they have at the end, which is a future value. And here I'm just going to put N as time times F2, which is 20 times 26, which is 520. Yeah. I've already solved for I2, so I already have I, so I don't need to jot that down here. So I think we're ready to solve for the future value, right? Let's just have a look at the formula sheet. I want to find the future value, and we're given a nice formula for that. Looks like we have all the components too. So we can just start plugging things in. The future value is $300 times 1 plus I2 to the power of 520, then minus 1 divided by I2. Yeah. I say I2 because I already calculated it up here. So that's fine. If you want to write it all out, that's okay, I guess. So now I have 300 times, I'm going to use brackets kind of excessively, right? Just making sure that it's applying things the way I want it to. 1 plus I, okay. And it recognizes that that's a value to the power of 520. Step it down, minus 1. And then close that bracket divided by I again. Let me see if that matches what it's supposed to be. Oh, I see my mistake. It was $200. Uh-oh. You know what? I'm going to change it here because the only change is there. So it's still salvageable. Phew. Okay. I'm going to screenshot this. Change this, pretend nothing ever happened, right? Because the payment amount is 200 and I don't know where I got 300 from, but let's just change these to 200s. There. So the future value, how much they would have in the savings account after 20 years, it's quite a bit. $154,476.02. Mm-hmm. Nice. So a little bit of work, right? Especially for me, keeping track of the payment amounts. But let's do it on our calculator, right? So now we will solve this on the calculator. And the interest per year, oops. I think it's the present value, the payment amount, the future value, the payments per year, the compoundings per year, and beginning or end. We have a lot of these components already, right? And so we know that N is 520, right? It has to be the number of payments. The interest per year was 3.75, I think. Yep, 3.75. The present value is what? Has to be 0, right? We're not told that they have, $10,000 initially, right? They could, and we'll see a problem like that, but they start with nothing, and then they are making payments, right? And so these payments are negative, right? Because they're going into this account. So 200 negative, right? If you're making payments, it's negative. The future value is what I want to solve for. The payments per year is 26, and the compoundings per year is quarterly, I think it was. Yeah. Yeah. And they're at the end of every 2-week period. Here, the calculator solves for I2 as well. By telling it that these things are different, it solves for I2 just in the background. All right, so I think we're ready to. Oh, of course. Why does it look so funny? There. All right. So let's plug these things in. So we've got 520 for your N, 3.75 for the interest per year, 0 for the present value, 200 negative for the PMT, I'm gonna plug in 0 for the future value just so I enter things into all of them, all the buttons. Now for the payments per year, so second payments per year, I'm gonna change it to 26, enter. Scroll down, compoundings 4, enter. And we're already in end mode, so that's good. And let me just confirm, payments per year, 26, compoundings per year, 4, good, so I can quit. Now, compute future value, compute future value. So now, let's just crop this. There. Which is the same, right, as what we found by hand. So you only have to do one of the ways. So whichever one you choose is fine. But I like the calculator. Okay. Let's do another one, but it's actually one that we need to use the calculator for. We don't need to use the calculator for it, but it's just a little bit too big for us to solve without the calculator. So now I want to solve, I want to do 221. Well, that's not actually the one I thought. Let me see here. I have 220. I just want to make sure that this one does the same thing. Okay, sure. Copy. I just don't have answers to compare it to, that's all. So here's one of those where we actually start with some value, right? And then we're adding on to that value. So compute the future value. So we're already told to find the future value of an RRSP, which is currently worth 25,000, okay? And will increase in value with month-end contributions of $500 over the next 12 years. Okay? Assume that RRSPs earn an interest at a rate of 9% per year, compounded semi-annually. Okay, and so here we're given, we want to find the future value. The present value is 25,000. And the payments per year is month end. So monthly, so 12 at the end. And the payment amount is 500. And the time is 12. So all I'm doing is, instead of kind of attaching it to the different spaces here, so we want to find the, I'm just attaching myself to all the key information and just kind of jotting it down, right? For 12 years, the rate is 0.09 and the compoundings per year is semi-annually, so 2. So now I'm going to organize this as calculator inputs, remembering that the negative and the positives make a difference. Let's say that, okay, in order to have this 25,000 already in there, because I'm not taking it out, right? I'm not getting it, right? Then it has to be negative. That's a tricky part, right? That's kind of tricky, but that's how it works. So you've got N, You've got your interest per year. You've got your present value. You've got your PMT. You've got your future value. Payments per year, compoundings per year, and beginning or end. Month end contributions for 12 years. So it's the time times F2, which is 12 times 12, 144. Oh, I forgot that this isn't the same question that I have. So I was looking at my notes and none of it matched. That's okay. I forgot. The interest per year is 9. The present value is, like I said, negative 25,000, right? And so negative 25,000, it's negative because we're not getting it, right? So this value is negative because we are not getting 25,000, right? So unless you're getting 25,000 and you can spend it on whatever you want, then it's going to be negative. Yeah. The payment is also negative, right? Because you're contributing $500. So negative $500. We want to solve for the future value. The payments per year were monthly, so 12 at the end. May as well jot it down as it appears. And the compoundings per year were 2, semi-annually. Yeah. Okay. So now, just doesn't want to come out and play. Okay. Maybe it's okay. A little squish, but that's okay. Let me just confirm 12 times 12, my 12 times tables. Yeah, 144. 144 and 9 interest per year, 25,000 negative is the present value. So you're already starting with that value and then you're making contributions of 500. So 500 negative is the payment, 0 for the future value because I'm about to fill it in later. Second, payments per year. I need 12 payments per year, enter. Compoundings per year, 2, enter. And then because it's all smushed right now, I'm just going to scroll around and make sure that it's doing what I want it to do, which it did. Second, quit. And then the future value. So now I can compute future value. And I get 199, 292.88. Let's see if I can.
I'm senior biotech analyst John Vandermosten.
Sorry, guys. But it's free. Can't get this thing to go away there. 0.8821. Notice that it's positive. So in theory, at the end of all this, I would get $199,292.88. So the total value after 12 years is $199,292.88. Okay. Just get organized here. So I didn't think we would get this far, but that's okay. We're ready. Okay, so I think we're ready for chapter 7. So chapter 7 is on annuities due. So chapter 7 is on annuities, or maybe it's not called annuities due. I know 7.1 is. 7.2. Sorry, let me just flip through here just real quick, because what is it called? I want to know what chapter 7 is called. I knew it. More on annuities. Yeah. I knew it was something ridiculous like that. More on annuities. Huh? We learned the basics of annuities, right? It's basically just regular payments are happening, right? And we don't need to calculate each one of them individually, right? And so that's the key part. And 7.1 is on annuities due. The only change with annuities due is that the payments are made at the beginning of the payment period. Payments are made at the beginning of the payment period. Okay, that's the change. Our timeline changes slightly, right? Just to indicate that the payments are made at the beginning of the payment period. Okay, so the timeline changes slightly to indicate payments are at the beginning. So what that looks like is if you have a timeline that looks like this today, and then I have 20 years or something like that, and I'm making annual payments. So 1 year, 2 year, ... 19 years, for example, right? Just making this up. What happens is, okay, so previously our payment amount was here, right? This first one, right, is at the end of the year from today, right? The second one is at the end of the year 2 years from today, right? At the end of the year 19 years from today, and at the end of the year 20 years from today. So what happens is this payment, right, instead of being at the end, is now at the beginning. Okay, and so now what happens is if this is at the beginning, right, then these all get shifted to here. Okay. So it now looks like this. One year, 2 years, 19 years, and 20 years. First payment's today. Second payment is a year from today. Third payment 2 years from today. The last payment is at the 19-year mark, right? The day after 19 years, right? The beginning of that year. So there's no payment here. So notice there's no payment here, but there is a payment here. Otherwise, everything stays the same. Okay. And so now we can still find future values, present values. Okay. But these can trace back to some present value due. Okay, so we need to indicate that, okay, these payments are actually at the beginning, right? Or we can trace them back to some future value due. Okay, so you use that little subscript due to indicate that it's at the beginning of the payment period. Okay. What's the difference going to be? If I make this payment basically a year earlier, right, then I have a year of interest that I wouldn't have had before, right? In this scenario, right, I wait a year and then I make the payment. That's a year where I could have been earning interest. Okay? And so now we're going to be earning interest on this first chunk of time. Right, and everything is going to be shifted just kind of to the beginning. Okay. And so here, let's see here. So a future value due, let's just jump to the formulas. Okay, so like I said, the future values, present values, and the ends for due, right? So when payments are at the beginning, are all going to be over here on the formula sheet. Copy. I'll paste it in again so we can talk about it. And maybe delete this one. So here, notice that we've got these subscript due everywhere. Okay. And that's really kind of the only difference, except that now we have this extra payment period of interest. Okay. So this is one extra payment period of interest. Right, 1 plus I. Besides that, everything stays the same if we kind of trace back to, right, comparing these values. So here we have ordinary annuities, payments at the end. And here we have annuities due at the beginning. But if you go through and you compare these formulas, right, PMT, PMT, times 1 plus I to the n minus 1 over I times 1 plus I to the n over I, right, or minus 1 over I. And then the only change here is the 1 plus I, right? It's going to make a difference just slightly, but it does change it. It does change the value. So that's why it's important, right? And then if we compare the next formula, PMT, okay, 1 minus 1 plus I to the negative n, 1 minus 1 plus I to the negative n over I, good. And then we've got this 1 plus I on the end. Okay, so here, it's the only difference. It's kind of like spot the knot. First formula for n, the log of 1 plus I to the future value due, right? And not just the payment, but the payment times 1 plus I. Okay. And so here, it's the future value due and the 1 plus I. So again, just taking into account that extra payment period of interest. Same thing with the next one, the next n. The only change is that now you have a present value due and the 1 plus I times the payment amount. Because it's the payment plus interest for one period. How we use these formulas. So we use these formulas the same way, regardless of when the payment period or when the payments are made, right? So if you're solving for the future value, solving for the present value, solving for n, solving for the payment, right? So we use the annuities due formulas the same way we used the ordinary annuities formula. So same way, only change is that 1 plus I, right? On our calculator, the only change is that we need to change the mode from end to beginning, is that we need to change the mode from end to begin. Okay, and so to do that, let me grab a screenshot. Let's see here if I have one. So to do that, you're gonna go second, begin. Maybe I'll make these a little bit bigger. And then second, set, to change it. To switch between modes. When you're in begin mode, okay, it'll show up. I guess I do need a fresh screenshot because we haven't used it like this yet. Okay. But if you go second begin, second set, then second quit, notice how it shows that little BGN. Okay. Done, save. This can go away there. Crop. So here, if you are in begin mode, it'll show up here, right? Even out of that menu. So if you are in begin mode, it will show here. Okay. So if you don't want to be in begin mode, then you just want to check the screen and it'll kind of prompt you if you're in begin mode by showing it at the top. Okay. Okay, but that's the only change, right? So in terms of using the calculator, it's not that big of a deal, right? But kind of in theory, what's happening is that there's interest on that additional payment period that you weren't getting or paying before. Okay. I don't want to do that. Do I have my chapter 7 examples here? Are they around here somewhere? Problems and solutions. Hey, here. Up to the top. Let's do example 224. Again, I'm first going to solve it by hand, then I'm going to solve it using the calculator, right? So maybe we will first solve by hand, then using the calculator. So payments of $350 are made at the beginning of each month toward a car. Okay. So now we're paying attention to that beginning, right? What's the car worth if payments continue for 5 years and money earns 4% per year compounded quarterly? And so here, let's kind of highlight things. So the payment amount is $350. The mode is the begin mode. At the beginning of each month, so the payments per year is 12, okay, which is also, in terms of calculating I2, it's your F2. Okay. What is the car worth? Okay, so that's asking for the present value. Okay, the present value, so what's it worth today? Okay. If payments continue for 5 years, so T is 5, and money earns 4%, so R is 0.04 per year compounded quarterly, so F1, which is the compoundings per year, is 4. First thing I'm going to do is I'm going to make my timeline, right? Very similar to before, except the last thing I do is I shift all my payments to the beginning of the payment period. So here I am today, and I got a car. That's not a very nice looking car, but anyways. And then 5 years from today. Payments are made at the beginning of each month. Okay, so here I am at 1 month, 2 months, ... 5 years has how many months? 60 months. So 59 months is when I make my last payment. Right? So now instead of starting and drawing my $350 payment at the 1 month mark, I shift it to the beginning, right? There's still the same number of payments. It's just that they're at the beginning now. So I'm going to make that shift 350, 350, 350, 350. And that's my last payment. Okay. These are all going to trace back to a present value due. Sorry. That due throws people off sometimes, but that's just because it's an annuity due, right? Because payments are at the beginning of the payment period. So N is 60 payments. And when we're working by hand, right, I should have started by finding I2 because I want you guys to be really good at finding I2, but I can do it now. I2 is 1 plus I1 to the power of F1 over F2 minus 1. 1 plus 0.04 divided by 4 to the power of 4 divided by 12, then minus 1. I'm also going to set up my present value formula. Or let's see, I have the value here. I'm just going to jot it down. We'll do it on the calculator as well, but 0.0033222284. You have to keep all your decimal places until the very end. It's very, very important for these questions. All questions, when it concerns money, right? People are kind of upset if you round too early and they lose out on $500, for example. They don't like that, right? So as soon as you're dealing with money, you're never rounding anything ever until the end. 2 decimal places. Okay, so I want to find the present value due, which from the formula sheet is this one here. Maybe I'll do this. So the payment amount is 350 times 1 minus 1 plus I2. Because I already solved for it, I'm just going to write I2 minus 60. Close the big brackets over I2 times 1 plus I2. Oops. Okay, it's the only change. Now,
I'm senior biotech analyst.
Yeah. There. So I'm going to start with 350 bracket. Hey, this isn't the calculator I usually use. Maybe I should just to kind of show you guys the store function in action. How about we do that? So usually I like the Desmos calculator better, but maybe this is the one that you're using. So then the first thing I would do is solve for I2 and store it. So 0.04 divided by 4 equals 0.01 plus 1. to the power of bracket 4 divided by 12 end bracket equals -1. Being really careful with all your brackets because it doesn't really show you everything. So then I'm going to store this in 1. So you hit the STO button and then whatever slot you want to store it in. Okay? And then just to make sure that it works, you can do recall 1 and then you should get the same number. So now we can use that. So I'm going to start inside and build my way out because this calculator is not as user friendly as the Desmos one. So I'm going to start inside here, 1 plus I2, which I've just stored in 1. Okay. And then I'm going to take it to the power of -60, and then 1 minus that, and then divide it by I2, and then times 1 plus I2. Okay, so I've got 1 plus recall 1 is that to the power of 60 negative equals then 1 minus that previous answer. Right, so the previous answer, you can go second equals as the answer, previous answer, divided by recall 1. Why is it negative? Shouldn't be negative. Did I do 1 minus? Okay, I better start over. I did something wrong. 1 plus recall 1 to the power of 60 negative equals 1 minus that previous answer. Okay, good. Now divide by recall 1. That doesn't make sense. It shouldn't be getting negative because I'm taking a positive divided by a positive. So what's happening here? That doesn't make sense. Recall 1, okay. 1 plus recall 1 equals to the power of 60 negative equals, okay. I'm going to store that in 2, just to store in 2. And then I'm going to do recall 2 divided by recall 1. Recall 2 divided by recall 1. I'm only hesitating because I have a different answer here. Okay, I'll just keep going. Times 1 plus recall 1 end bracket times 350. Am I not doing this? Am I doing -1? I thought I was doing 1 minus. Okay. I'll try it one more time and then I'll try it on my Desmos one. Okay, I'm just going to jot this down. 86625.21626. Okay. 1 plus recall 1 to the power of 60 negative equals 1 minus that. Okay. I'm going to store that in 2 divided by recall 1. There. I must have been subtracting 1 when I shouldn't have been. Okay, not that. This matches what I have in my notes. 54.31671541 times 1 plus I2. I'm going to store this in 3, just so I have it. And then times 1 plus recall 1, 5449, okay, times 350. Phew, okay, now I get the same. I'll clean this up, but I want to close this troublemaker. Or maybe I'm the troublemaker. There, wasn't doing things carefully enough. So we have 350 times 54.31671541 times 1 plus I2. And delete this, move this up. $19,074.00983, which is 19,074 and 1 penny. There. Yoof. Now let's use the calculator. And I promise it'll be a lot easier and a lot quicker. The longest part is writing out the entries that you need. So now solve with the calculator. N, interest per year, present value, PMT, future value, payments per year, compoundings per year, beginning or end. And here we're at the beginning, right? So you have to make sure that you're in the begin mode. As long as you change it before you compute the value, of course, it doesn't matter when you do it. I like to do it at the beginning so I don't forget. Okay. So the tricky part with using the calculator, right, is the negatives and the positives, right? But let's see here. Our N is 60. The interest per year was 4. And it was compounding quarterly. So I'll write that down right away. The payments per year were monthly, 12. The present value is what I want to solve for. The payment amount is 350. Now, because I'm paying this amount, I have to make it negative. And the future value, once it's all paid off, the value of the loan should be 0. Right? Just like that, we have all the things that we need. So now I'm ready to probably watch another commercial. No, we don't have to. Okay, great. So just make sure, so I'm already in begin mode, but I'm going to show you again how to get there. And so second payment, which is the begin, and then to switch back and forth, you go second set, second set. Make sure you're in begin mode. That's where I like to start. Second quit. And now we do the same thing that we have been doing. 60 into N, 4 for the interest per year. I'm going to put 0 into the present value for now. 350 negative for the payment amount. 0 future value. Second payments per year, 12. It's already set at 12, so that's good. Scroll down, but I need 4 compoundings per year. Enter. Just flip back and forth a couple of times. Just make sure it's how you want it. Looks good. Second quit. Now we can compute the present value. Compute present value. I'd say that's a lot easier than what me struggling with the formula. I've gotten lazy, I think. using that Desmos calculator, it kind of puts up with a lot of bad habits. And I just want to highlight, and maybe a better highlight. Right, just make sure that you're in begin mode. Nice. It's the same value that we ended up with, but it took me way longer to get to the first one. Nice. So then here, right, same as by hand. Finally. Nice. Okay. Let's do, just want to make sure that it is on. Okay. Let's have a look at the examples. Let's do example 227. Susie takes out a loan of $20,000 so that she can purchase a new car. She intends to pay this back with $175 installments at the beginning of each week. Okay. Assuming the bank charges a rate of interest of 3.5% compounded annually on her loan, how long will it take for her to repay her debt? Okay. And so what I want to do again is just solve it by hand and solve it using the calculator. Maybe I'll put it on a fresh page. I was debating, but there. Okay. We will solve by hand and using the calculator. Okay. So first thing first, let's highlight a couple of things. So we're told that, how about I just jump right into the timeline. Eek. Today, we haven't done that before, right? But today she borrows $20,000. Now, the amount of the loan is the present value, okay? And so this is going to be some present value due because it's at the beginning of each week, okay? Is $20,000. So these payments that she's going to be making are all to pay off this $20,000 today, right? She's going to end up paying more than $20,000 in the total payments, right? But that's how interest works. And so at the beginning of each week, so 1 week, 2 weeks, up to n weeks, and n minus 1 weeks, right? How long will it take? So that means that we first have to find n, and then we can find t. $175 at the beginning of each week. So when it's at the beginning, I shift them all over to the left one, like that. Okay. These are all going to funnel back to some present value due, right? Which we know is 20,000. And we want to know what n is. Okay. Really, we want to know what time is, right? So what's the time is really what we need, but in order to get there, we first need to know the number of weekly payments, and then we can go from there. So we need the F2, which is the payments per year, is beginning of each week, so 52 payments per year. F1 is the compoundings per year, compounded annually, and R is 0.035. First thing we need to do is find I2. I2 is 1 plus I1 to the power of F1 over F2 minus 1. 1 plus 0.035 divided by 1 to the power of 1 over 52 minus 1. Let me see if I have it here. Okay. 0.00066178.5. Now, if we're trying to find n, right, it's really important to remember if we have a future value or a present value. And then if we have just a regular present value or a present value due. Now, in this case, we have a present value due, which means that my formula that I need to use is this one, right? I have two options for annuities due for solving for n, and I have a present value, so I need to use this one. Right, because this is what I have. N is the negative log of 1 minus I2 times the present value due, which is 20,000, divided by the payment amount, which was 175, times 1 plus I2. Close that bracket, divided by the log of 1 plus I2. To save myself some grief, how about I just use this one? I know I can't handle it. I is equal to the negative log of 1 minus, oh, I jumped to the n. I is going to be 1 plus 0.035 divided by 1, close the bracket, close the bracket to the power of 1 divided by 52, and then minus 1. 66178. Okay. Now I'm ready. I want the negative log of 1 minus I times 20,000, 1, 2, 3, divided by 175 times 1 plus I. Close that bracket. Just make sure it looks the same. 1 plus I, 175. Okay. Close that bracket for the log, and then divided by the log of 1 plus I. Whew. Not too bad when we're using Desmos, right? But pretty bad if we're not. Gonna paste the, oops. Crop this. So we would need 118.796 payments. Okay. Now, if you just went to 118 payments, you would make it to here, right? And then 0.796 gets you the rest of the way, but we need 19 payments, right? So we always need to round up. So we would need to make n equal to 119 payments. So n is time times the payment frequency, which means that 119 is time times weekly, which is 52. So time can be a fraction, right? Time is going to be 119 divided by 52, which is 2.29 years. So 119 divided by 52, 2.288461538 years. And I'm only gonna, I want to write out the proper value here. I'm not going to keep this 2.288461538 years. Okay. Nice. All right. And with that, we actually finished 7.1. So what I'll do is I'll kind of rejig the assignment. I didn't think we would get this far, but I'll rejig the assignment. I'll also post a quiz for you guys to work on. And then we'll continue chapter 7 next week. If you have any questions, let me know. Otherwise, I hope you have a wonderful weekend. Feels like a ways off, but and I'll see you on Monday.